Hello guys, this is Paul McWhorter with TopTechBoy.com, and I'm here today to talk to you about some very common math mistakes. And I want to talk to you about these math mistakes because I want you to hone and sharpen those math skills. Now, one of the things you guys probably know is one of the things that I do is I teach high school math. And as a high school math teacher, I give lots of math homework. And because I give lots of math homework, I grade lots of math homework. I teach math all the way from freshman, starting in algebra and going all the way to advanced calculus. And so I teach a lot of math classes in high school. And what I want to share with you today is what I find are the most common mistakes that high school students make in math. And if my students are making these mistakes, could be that you are mistaken about these things as well. And so I want to show you the 5 most common mistakes that high schoolers make in math. And this has been for a long time, and so it could be that you are confused about these issues as well. Why is this important? Well, you know, Top Tech Boy is really about engineering. It's about projects with things like the Arduino and the Raspberry Pi. But a lot of times when we get into these things, we find ourselves needing to do calculations. If you've gone through our series of Arduino and Raspberry Pi lessons, you see a lot of times we've got to calculate the slope of a line, or we have to do various calculations to make the magic happen. And so I want you to be good not just at programming, I want you to be good at math. And for you to be good at math, you need to not make these mistakes. So mistake number one mistake I see when I'm grading mathematics all the way from freshman high school to senior high school is this one, okay? A plus B squared. What does a squared plus b squared equal? Well, apparently a lot of you think that a plus b squared is equal to a squared plus b squared. It's like you see the 2 and you just distribute that 2, you distribute that squared, and you say a plus b squared is a squared plus b squared. That is wrong. That is wrong every single time. Now, why is it that you do that? Well, probably because you're thinking, you remember you learned 2 times a plus b. What do you do there? In that case, correctly, you would distribute the 2, and so that would be 2a plus 2b. Okay, that's correct. When the 2's out front, you distribute it, you can get rid of the parentheses, and it looks like that. And because you know this is true, you just kind of think, well, this looks sort of like this, and so I'll just kind of take the parentheses off and distribute the 2. No, 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 no. Wrong. Don't do that. That's crazy math. That's crazy math. You'll miss it every time. So how is it that you can sort of understand this and know what the right answer is so that you can really think about it and understand it? Well, let's think of the simpler case. Let's just go back to the definition of squared. If I ask you, what does x squared equal? If you take a number or you take a variable and you square it, what does that mean? Well, most of you would tell me that that is x times x. And I really like it when you use your parentheses even when you don't have to, because it really shows that you're taking those 2 numbers and multiplying it. Okay, so if I ask you what is x squared, you would say, well, that's obvious. That's x times x. Well, what if I ask you what is apple squared? Okay, if I ask you what apple squared is, hopefully you would tell me that that's apple times apple. Okay, hopefully you would tell me that. Well, what if I ask you then, what is a plus b? What is a plus b squared? Well, hopefully you'll sort of see what I'm doing here, that a plus b squared should be a plus b times a plus b. Okay, a plus b times a plus b. That, my friend, is correct. But now, it is true that in most cases you need to go ahead and do a little more manipulation. So how are we going to multiply this out? Well, a lot of people call it FOIL, but basically you just take the first term and multiply it by the next one. So a times a is a squared, and then plus the next term, a times b, a times b. So we have a times a is a squared plus a times b is ab, and then we move our finger over to the b term, And we do the same thing, plus b times a plus b times b. And b times b is, you guessed it, b squared. Okay, now we have 4 terms, but after we've multiplied things out, what we've learned in algebra is the next thing we need to do is combine like terms. We know a times b and b times a, because the commutative property can be moved around. B times a is the same as a times b, so we combine these 2 like terms and we get the correct answer, which is a squared plus 2ab plus b squared. Okay? And we say a plus b squared is equal to this. Okay, this is correct. That is the correct answer. Well, what's the difference between here and the way we did it wrong to begin with? We're missing this cross term of 2ab. You get the a squared, you get the b squared, but what you got to see is there's that cross term of 2ab, and when you just distribute the 2, you don't get it. Please don't make this mistake. I see it over and over and over. I talk to my students. I beg them, don't do this, but it happens over and over and over. And if you're doing a programming problem, maybe trying to calculate the power that you should put to a given component, or running a servo, or brightness of an LED, and you end up with a quadratic where you have to multiply this out, and you do this, it's kind of close to the right answer sometimes, but because you don't have this term, it's never going to work right. So for your project to work right, you've got to do the math right. Number 1 mistake that I see, number 1 is this one. Okay, that's the number 1 mistake. Okay, what other mistakes do I see over and over? This is the number 2 mistake that I do not want you to make, and that is dealing with fractions. B plus a over a. Let's say, what is it that you do? Well, you remember somewhere back in 3rd grade they taught you that if it's in the numerator and the denominator, it cancels, right? You were taught about canceling. And so you look at this and say, oh man, I'm going to cancel the a's. And so I'm going to have b plus a over a is equal to b. Okay, that is wrong, because I'm going to have to break some news to you. There is no such thing as canceling. No such thing as canceling. If you look at real mathematics, if you look at real algebra, there ain't no such thing as canceling. Now, I know you were taught that. I know your teacher taught you canceling, but he or she was wrong. Okay, there's no such thing as canceling, because even though what they taught you was the proper use of this technique, you grow older, get to harder problems, and then you start improperly applying it. So I'm just going to suggest there's no such thing as cancel. Never cancel. Okay, some of you are a little bit more sophisticated, and what you would say is b plus a over a. You would say, well, this a and this a make 1, and so that's equal to b plus 1. You know what? Guess what? That is also wrong. That is wrong. This is crazy math. This is crazy math. This is crazy math. Okay, so how would you deal with this if you have b plus a over a? What does it equal to? Well, this is the way you got to think it. You've got to go back to the real rules of algebra and only do the real rules. Okay, what is the real rule? Well, you can break that up as a fraction. And you can say that that's equal to b over a plus a over a. Okay? And now b over a is b over a. What's a over a? It's 1. And so the correct answer would be b over a plus 1. That is the correct answer. But you see, you've got to work it without canceling. Okay, so how do we get off on this whole canceling thing to begin with? Why were you taught that? Well, you were taught that as a little trick, a little shortcut to where you could simplify a problem. And what you were taught is if you have a times b over c times a, you were taught that the a's cancel. There's an a on the top and the a on the bottom, and they cancel, and therefore it's equal to b over c. Well, b over c is the right answer, but I would suggest to you there's no such thing as canceling. And when they teach you canceling here, okay, which gives you the right answer, when you get to this problem and you're in high school, what do? You cancel. And what do you get? The red pen. You get the red pen because there's no such thing as canceling. So even on this problem, how would we work this problem correctly without canceling? Well, I could say that A times B over C times A. Remember, the commutative property says that when we have two numbers multiplied together, the order doesn't matter. We can change the order, so we can change this. A times B is equal to A times B, and so we're just going to leave that A times B over, and then down here I want to put the A in front, so I can commutative property, switch the A and the C, and say that's equal to A times C. Okay. Now, also what I can do is I can break this into two different parts, and so that's equal to A divided by A, right, that part, times B divided by C. Okay. Now, do I cancel A and A? Do I cancel? No. A divided by A is equal to 1. So this is equal to 1 times B over C. Okay. Do I have to write the 1? No, I don't have to write the 1, so that's equal to B over C. This is the right answer. This is the right answer, worked the wrong way. This is the right answer, worked the right way. And so what I wish that we would stop teaching students these little shortcuts that don't exist, like canceling, because then when we get to harder math, something like this, we fall back on those old rules which don't apply to these problems, and we cancel. So let's just start doing real algebra. This is real algebra, getting the right answer the right way. Okay, getting the right answer the right way. Do the real algebra. So number one mistake, when you square something, you don't just distribute the square. You have to write it out. You have to write it out, and then you have to multiply it out. Number two, never cancel, because most of the time when you cancel, you're canceling when you shouldn't. Okay, so let's look at another thing. So let's look at problem number 3. The third most common mistake that I see is, let's say that we have a good old-fashioned algebra problem like 3 over x is equal to 4 over x plus 1. Okay, 3 over x is equal to 4 over x plus 1. Well, you see these fractions, these kind of ratio fractions, and you remember what you were taught back in the 4th grade or whatever. You think what? Cross multiply. Okay, I'm going to tell you something. There's no such thing as cross multiplying. Again, it's one of those little rules that will work in a few cases, and they teach you that, and then you get to a harder problem and try to apply it, and it doesn't work. So what would cross multiply say? Well, I'll take the 3 multiplied by the x, and so I have 3x, and then is equal to the 4 times the x. So I go that times that is equal to that times that. Okay, and then I have the plus 1. Okay. And then what you could probably do is you could subtract the 3x from both sides. So you could say that that's going to be equal to x, because I'm going to subtract 3x from both sides. And then I'm going to subtract 1 from both sides. And so you're going to have x is equal to minus 1. Okay, that is wrong. You get the red pen. Okay, that is wrong. Why is it wrong? Because there is no such thing as cross multiplying. Even though you were taught cross multiplying, it was only for a very specific problem like 3 over x equals, let's say, 1 over 4. And in that case, you say cross multiply, you would say 12 is equal to x. Okay, that is the correct answer, but it's worked the wrong way. Okay, what I want you to know is that most of the problems in math that you're going to encounter in high school you can solve with one simple rule. Whatever you do to one side of an equation, you do to the other side of the equation. That will be true from when you're a freshman to when you graduate college. Whatever they're teaching you to do, if you do it to one side, you do it to the other. So if I square one side, I square the other side. If I find the Farfanugan of one side, I find the Farfanugan of the second side. There is no such thing as a Farfanugan, but if there was, you would do it to both sides. And so much of math will work if you will say, okay, whatever I do to one side, I will do to the other. So let's apply that and work this problem. Was that hard? Whatever I do to one side, I do to the other. So let's look at this. I have 3 over x equal 1 over 4. Well, why do I not like this? I don't like these denominators. I especially don't like that x in the denominator. So what could I do to both sides? What if I multiply both sides by x? I'm going to get that x out of the denominator. So I have 3 over x times x is equal to 1 over 4 what? Times x. Okay, x over x, the x's cancel, right? No such thing as canceling. X divided by x divided by x equals 1. And 1 times 3 is 3, is equal to x over 4. But now I'm trying to solve for x, and I'm getting kind of closer. I'm liking this a lot more because I don't have x in the denominator, but now I need to get rid of that other denominator, that 4. What could I do to both sides of the equation? I could multiply both sides of the equation by 4. And so here I have 4 times 3, always use your parentheses, is equal to x over 4 times 4. Okay, then 4 over 4, the 4's cancel, right? No such thing as canceling. 4 divided by 4 equals 1. And x times 1 is equal to x, and 4 times 3 is equal to 12. Okay, so was this that hard? This is the right answer worked the right way. This is the right answer worked the wrong way. Well, you said this I just did in one step. Yeah, but when you come over here and do it in one step for just a slightly different problem, you get the wrong answer. And believe me, I have to buy boxes of these things because people cross multiply, which there's no such thing as cross multiplying when they're not supposed to. So then how would we work this more complicated problem? Well, let's think about it. 3 over x is equal to 4 over x plus 1. Well, why do I not like this? I don't like variables in the denominators. How could I get the variable out of the denominator? What could I do to both sides of the equation to get the x out of the denominator? You got it. Multiply both sides of the equation by x. Okay, now I want to show you the right way to do it. Use your parentheses. So I'm going to say x times 3 over x is equal to 4 over x plus 1. Okay, and then I got to put parentheses in and multiply that side of the equation by x. Okay, so x over x cancels, right? No. You know that now. X over x equals 1, and I'm left with 3 is equal to, okay, now I distribute the x, so I have 4x over x plus x. Okay, what happens here? X over x equals 1. 4 times 1 is 4, so I have 3 is equal to 4 plus x. Now what do I do to get x by itself? I subtract 4 from both sides, and so I have minus 1 is equal to x. So I can say x is equal to minus 1. Okay, so that is the right way to work the problem. Now let me show you. Okay, so this is, what is this? This is the number 3 thing. There is no such thing as cross multiplying. Okay, now I worked this problem the right way to the right answer, but I'm going to show you the number 4 thing of one of the most common mistakes that high school students make that lead to wrong answers is not using the parentheses. When you do something to one side of the equation and do something to the other side of the equation, you have to use your parentheses. So I'll show you, this is how I work the problem. Right answer, right way, green pen. Hey, look at that. My green pen is invisible. Look at that, invisible green pen. That is pretty neat. Red pen you can see. Okay. Let me show you how to work the problem the way that most of you would work it. Okay. And so I'm going to say that 3 over 4, I'm sorry, 3 over x plus, I'm sorry, 3 over x is equal to 4 over x plus 1. Okay? Whatever you do to one side of the equation, you do to the other. What do I want? What do I wish? I wish I didn't have x in the denominator. So what can I do to both sides of the equation? Multiply both sides of the equation by x. And so I'm going to say x times 3 over x is equal to 4 over x plus 1 times x. So I multiply both sides by x. Oh man, you can't see that. Okay, there. Okay, I multiplied both sides by x. All right. This, okay, and then what would you get? You would have 3 is equal to 4 over x plus x. Okay, and you can see that this is not getting to the right answer. What did I do wrong? When you multiply both sides, you have to multiply all of the both sides by the same thing. So what did I not do here? I didn't use my parentheses. You have to use your parentheses. Then you multiply x by the whole thing on this side, and then the x distributes, and then you get down here like this, and you get the right answer. You get the right answer the right way. And this is really, really, really where it gets important. Like if I have x plus 1 over x plus 2 is equal to, let's say, 3 over 4, just say something like that. Well, what do I want to do? I want to get rid of the denominator. So what do? I multiply both sides. You've got to use parentheses all the way around. So what do? I have x plus 1 over x plus 2 with parentheses times with parentheses x plus 2 is equal to 3 over 4. Let's see what happens if I did not use my parentheses and just said x plus 2. Okay, if I just said x plus 2, why is this going to be wrong? Because the 3/4 is just going to multiply the x, not the plus 2. So when I multiply by x plus 2, I've got to multiply all of x plus 2 by both sides. How do I do that? I have to use parentheses. Okay, so what would I have now? X plus 2 over x plus 2 cancel? No such thing as canceling. X plus 2 over x plus 2. It's like apple over apple, avocado over avocado, Guadalajara over Guadalajara equals 1. X plus 2 over x plus 2 equal 1. I'm left with x plus 1 is equal to, now distribute the 3/4. 3/4 x plus, we could say that would be 6/4, but what we could also see is that reduces down to 3/2. Okay, now what I could do is combine like terms and solve for x. At this point you should be able to do it. Okay, so number 1, a plus b squared does not equal a squared plus b squared. Number 2, there is no such thing as cross multiplying. Whatever you do to one side, you do to the other side. Then, when you're multiplying both sides by something or doing something on both sides, put big parentheses on both sides and then put big parentheses on whatever it is that you're doing to that side. Okay? And that will really, really, really help you get a whole lot more correct answers when you're working high school algebra problems or when you're working engineering problems, because algebra pops into these problems over and over and over. Okay. Now, one other thing, I don't know if you've gotten into logarithms yet or not. Logarithms is a way to sort of squeeze numbers down. It sort of takes big numbers and sort of squeezes them. But this is one of the most common mistakes that I see in logarithms. Let's say that I had the problem log of A plus log of B is equal to log log of C. What you have to understand is things like log are functions. This is log of A. It's some function that you're doing on A, just like sine of x is some function that you're doing on x. This is not log times a. And so what I will see students do all the time, they'll come in and say, oh, there's a log here, here, and here, and I'll get rid of those, and then I'll have a plus b equals c. Okay, that is wrong. Red pen. You do not get to just drop off a function. Just like if I have sine of x plus sine of y is equal to sine of z, you cannot just come in and mark the functions off. It's not like multiplication. You can't just drop them off. What could you do here? Let me write this out, show you how you would do this correctly. Log of a plus log of b is equal to log of c. Well, what does log of a number plus log of a number, how do you combine that? That is equal to log of a times b, which is equal to log of c. Now I have log of something on one side, and on the other side log of something else. At this point I can undo the log. You can see at this point the logs would drop out. If we really wanted to do it correctly, we would say 10 to the log a times b is equal to 10 to the log of c, and 10 to the log, 10 to the log becomes 1, and I'm left with a times b is equal to 10 to the log of c is equal to c. Okay, so this is a little bit more complicated, but the thing is that if you take a function of something plus a function of something equals a function of something, you can't just go in and drop the function off. That is never right, but you kind of do that because it's almost like you're thinking that you're dividing both sides by logs, but there's a difference of a function versus just multiplying, and so that's something that you don't want to do. Okay guys, I hope that you found this helpful, and I hope that if you have things that you're struggling with in math, maybe put a link, put a question down below, and I'll probably make a few more videos. Let's try to improve those high school math skills, because whether you're in high school, if you're in high school, you want to do good on your math, and I see so many kids that are getting B's and C's in math when they should be getting A's because they're making these mistakes that I'm showing you. And again, the most important thing to remember in high school math is one simple rule. Whatever you want to do to whatever you do to one side of the equation, you do to the other. And whenever you do that, you use parentheses on both sides. Okay. The other thing that you got to remember is you've got to remember that when you're solving equations, a lot of times you want to get things out of the denominator. The way you get them out of the denominator is multiply both sides by whatever that denominator that is that you need to get rid of. You use your parentheses when you're doing that multiplication. And even if you're not in high school math, maybe you're up older and maybe you're just taking, learning to program the Arduino or learning to program the Raspberry Pi, I can promise you that your projects are often, I mean, if you're following my projects, you can just follow along, but you want to branch out. You want to start doing your own thing. You want to do things that I haven't shown you in my Arduino and Raspberry Pi videos. I can promise you that you are going to start running into the need to do simple math, and I hope that if you sort of brush up on your math skills here with this video, it will help you get good answers in math which lead to working projects in Arduino or Raspberry Pi or circuits. Good math leads to good solutions. Okay, hope you guys found this helpful. I'd love to hear your comments below. Paul McWhorter, TopTechBoy.com. If you like this, think about giving us a thumbs up. Think about subscribing to the channel. I will talk to you guys later.